Meta just bought a robotics AI startup. Waymo's doing 500,000 rides a week, and Tesla can't get past 25 cars. The autonomous systems race is splitting into winners and pretenders. Meanwhile, a collision prediction model trained on roads is suddenly working for drones and warehouses, and Ukraine is producing 140 times more drones per year than the United States. From the team at the Synthetic Daily, it's Saturday, May 2nd, 2026. Good to have you with us.
We went through 12 posts, articles, and threads across LinkedIn, Substack, and YouTube over the past week to dive deeper into the world of autonomous systems and robotics.
So here's the headline that landed yesterday. Meta Platforms acquired a startup called Assured Robot Intelligence. Bloomberg broke it. And the framing for Meta is fascinating. They describe this company as working at, quote, the frontier of robotic intelligence designed to enable robots to understand, predict, and adapt to human behaviors. That's not a chatbot play. That's not a content recommendation engine. That's Meta saying, we want AI that has a physical body and can work alongside people.
Exactly. Now, why does this matter beyond the press release? Because Meta has been the loudest voice arguing that AI needs to understand the physical world. Yann LeCun has been beating this drum for years with his world models agenda. And now we're seeing the corporate checkbook follow the research philosophy. Meta's joining a crowded field. Boston Dynamics and Hyundai have production Atlas units shipping to Google DeepMind. Figure AI just hit a $39 billion valuation off their BMW Pilot. Tesla's converting Fremont car lines into Optimus robot production. But Meta's angle is different. They're not building the hardware. They're building the intelligence layer. The part that lets a robot predict what you're about to do and get out of your way, or hand you a tool before you ask for it.
The timing isn't coincidental either. NVIDIA dropped their Isaac GR00T open models earlier this year. Natural language understanding for robots, synthetic training data via Cosmos world models, a new physics engine called Newton for simulating dexterous manipulation. The infrastructure for training embodied AI is suddenly available off the shelf. Meta's acquisition suggests they think the bottleneck has shifted from simulation tools to the actual intelligence models that run on those tools. The land grab isn't for robot bodies anymore. It's for robot brains. Okay, here's where it gets interesting. Luke Vincent posted something this week that deserves more attention than it got. He's talking about BADAS 2.0, a collision prediction model that launched about 2 weeks ago, trained primarily on road driving data. Here's what's interesting. The model is now getting adoption from warehouse automation companies, drone programs, humanoid robotics teams, and defense tech groups. None of those are cars on roads.
I want to add something to that. Vincent's argument is elegant and a little counterintuitive. He says the field has always assumed you need environment-specific models. Train on warehouse floors for warehouse robots. Train on aerial footage for drones. Train on roads for cars. The assumption being that these environments are just too different to share a single representation. But Vincent says that assumption confuses the environment with the underlying physics. Roads aren't special because they have cars. Roads are special because they're, in his words, maximally adversarial, high-speed, multi-agent, unpredictable. If you can learn to predict collisions in that environment, you've learned something deep about how objects move and interact in physical space.
This connects directly to the broader physical AI thesis we're seeing from NVIDIA and Meta. The idea that intelligence about the physical world is transferable, that a model trained in one domain carries useful representations to another, is exactly what makes embodied AI investable at scale. You don't need to train from scratch for every warehouse, every airspace, every factory floor. You train once in the hardest environment and then transfer. It's the same logic that made GPT work for dozens of text tasks. Vincent is showing it works for a physical prediction too. This next one surprised me. Let's talk about the numbers, because the numbers are brutal. Waymo is now doing 500,000 paid rides per week across 10 U.S. cities. That's a 10x increase in under 2 years. They've started testing in London. About 100 electric Jaguar I-Paces on public roads across a 100-square-mile area. And this week, Uber announced that Hertz will handle day-to-day fleet management, charging, cleaning, maintenance, depot staffing for their premium Robotaxi service with Neuro and Lucid Motors, launching in San Francisco by year's end. The ecosystem is filling in. It's not just the self-driving tech anymore. It's the entire operational stack.
Now contrast that with Tesla. Electrek reported that Tesla's unsupervised robotaxi fleet has grown to, and I want you to sit with this number, 25 vehicles. Total. Across 3 Texas cities. Austin, Dallas, Houston. 25 cars. Waymo has over 3,000. Elon Musk has been promising autonomous rides for years, and the gap between rhetoric and reality is now measurable in orders of magnitude.
What's really happening here is a divergence between two philosophies. Waymo bet on purpose-built sensor suites, LiDAR, radar, cameras, and years of structured testing. Tesla bet on vision-only systems and consumer vehicles doing double duty. The Uber-Lucid partnership is interesting because it's a third path, a premium hardware platform with solid-state LiDAR, NVIDIA Drive AGX Thor compute, and a dedicated fleet operator. They're not trying to retrofit consumer cars. They're building robotaxis as robotaxis. Wood Mackenzie is projecting a 10x growth in the global autonomous fleet by 2030, and the winners are clearly not going to be the companies with 25 cars in Texas. Now, shifting gears a bit, Azim Azad dropped a stat this week that stopped me cold. When Russia invaded in 2022, Ukraine had about 7 domestic drone manufacturers. Today, it has roughly 500. They produced 4 million drones last year. The forecast for this year is 7 million. And here's the kicker. Ukraine is on track to produce approximately 140 times more drones annually than the United States.
But the production numbers aren't even the most important part. Azar's Exponential View newsletter dug into something a Ukrainian drone pilot named Jack DeSantis told him. That soldiers who leave the front for rehabilitation and come back 8 or 9 months later need complete retraining, because drone warfare evolves that fast. And since that conversation, the iteration cycle has compressed to 7 days. 7 days from identifying a problem to deploying a solution in the field.
This is what a real-world learning curve looks like when survival is the optimizer. It's not a quarterly product roadmap. It's not an annual model refresh. It's weekly iteration under extreme selection pressure. And it connects to the BADAS story, because some of those drone programs reaching out to Vincent's collision prediction model are almost certainly operating in this kind of environment. When your iteration cycle is 7 days, you can't afford to train domain-specific models from scratch. You need transferable intelligence. You need models that generalize.
The defense implications are enormous, but so are the commercial ones. 500 companies competing on 7-day cycles is an innovation engine that no peacetime R&D lab can match. The question is whether that knowledge transfers back into commercial autonomous systems. And based on what we're seeing with cross-domain collision prediction, the answer is increasingly yes.
Here's a number that should get the enough attention of Western tech circles. The State Grid Corporation of China allocated approximately $1 billion in 2026 to buy AI-enabled robots. They're planning to deploy around 8,500 robots for power grid inspection and maintenance, specifically in remote and hazardous locations where sending humans is expensive or dangerous.
Which is wild, right? Because this isn't a research project. This isn't a pilot. This is a procurement order. And it tells you something about where China is in the embodied AI timeline. Roland Berger published an analysis noting that China has more than 50% supply chain overlap between humanoid robotics, automotive manufacturing, and what they call low-altitude economy, basically drones and urban air mobility, That overlap means automotive suppliers are pivoting hard into robotics. The factories that make car parts today are retooling to make robot components tomorrow. The workforce that assembles vehicles is learning to assemble humanoids.
And then there's the symbolic stuff, which in China is never just symbolic. A humanoid robot called Lightning, built by the Honor and Monkey King team, won the Beijing E-Town Half Marathon in April in 50 minutes and 26 seconds. That's nearly 7 minutes faster than the human world record. Running a half marathon requires sustained balance, energy management, terrain adaptation, and navigation in a crowded real-world environment. It's a flex, sure, but it's also a genuine engineering achievement that demonstrates readiness for unstructured physical tasks. Between the billion-dollar grid order, the marathon-running humanoid, and the supply chain convergence, China is building an embodied AI industrial base at a pace that should make everyone else nervous. All right, let's zoom out and talk about the bigger picture. What are the main themes running through everything we covered today? The first big theme is intelligence over hardware. The competitive moat in autonomous systems is shifting from physical platforms to the AI models that control them, creating a new acquisition market for robot brain startups.
Next, transfer learning goes physical. The same insight that made foundation models dominant in language, that representations trained in one domain generalized to others, is now being proven for physical world collision prediction and navigation.
Next, operational ecosystems beat solo acts. Robotaxi success increasingly depends on multi-party ecosystems handling fleet logistics, not just self-driving algorithms, which explains why partnership-rich players are pulling ahead.
Next, wartime-as-accelerant. Ukraine's 7-day iteration cycle demonstrates that extreme selection pressure produces rates of autonomous systems improvement that peacetime commercial incentives cannot replicate.
And the last one, state-scale procurement as market signal. Government purchase orders in the billions, not venture funding or prototypes, are the clearest indicator that embodied AI has crossed from research into industrial deployment.
So if you're going to take away a few things from today's episode, here's what I'd remember.
Number 1, if your AI model learns physics rather than environments, it can transfer from roads to drones to warehouses, and that's the foundation model moment for the physical world.
Number 2, 25 Tesla robotaxis versus 500,000 Waymo rides per week isn't a competition anymore. It's a case study in what happens when vision doesn't match execution cadence.
Number 3, the country producing 140 times more drones than the U.S. isn't doing it with bigger budgets. It's doing it with 500 companies iterating weekly under existential pressure.
And finally, when China's state grid spends $1 billion on robots in a single year, it stops being a technology story and becomes an industrial policy story, and those are harder to compete with.
That's the Synthetic Daily for today. All the sources and links are on the website if you want to dig deeper.
Thanks for listening. See you tomorrow.
BADAS.